We are live. Hi everyone, welcome back to Code Era. Today in this video, we'll be discussing the daily Geeks for Geeks daily practice problem for 2nd of February. The name of the problem is find positions of set bit. Previously, this problem has been asked in a lot of organizations like Microsoft and Amazon. So consider giving me a +1 in the chat if my voice is audible to everyone and my screen is visible. And then I'll start with the session. Right. So as I said that this particular problem is the problem in which you have to find the position of the set bit, right? So in this particular problem, what you have to do is you'll be given a number n and you have to find the position of the set bit, right? So what does it mean? So you will be first of all converting the number into a binary representation and then you have to return the position of the set bit. So you'll be given a number n and only one set bit would be there and others, all the bits would be not set, so there will be 0 in the binary representation of this number. You have to find the position of the only set bit, right? Is it clear to everyone? Is the problem statement clear to everyone? Because only then I'll be able to proceed further, right? So if there are more than one set bits, then the answer should be -1, and if there is no set bit, then in that case also the answer should be -1. So what you have to do is you have to return the position of the set bit, right? Let's say if you have n is equal to 2, right? If you have n is equal to 2, so if you have a number that is n is equal to, first of all let's discuss for n is equal to 0, right? If you have n is equal to 0, so that means that the number itself is 0, so its binary representation would also be 0. So in this case what you will do, you will simply return -1. What if n is equal to 1, right? If n is equal to 1, so in that case what will happen? Okay, Pranav, it's not clear. What is not clear, right? Okay, I'll explain the question again. So what the problem is saying is that you will be given a number n. Okay, you will be given a number n. Let's say I give you a number n, let's say I give you something like a 5. So you will be having its binary representation, right? Binary representation. So the for 5, the binary representation would be 101, like this, right? So if you have this particular binary representation, so if there is only one set bit, then you have to return the position of that particular set bit. If there is no set bit, if there is no bit in the binary representation which is 1, in that case you have to return a -1. If there are more than one bits which are 1 in the binary representation, then you have to return -1, right? So like if you have, let's say n is equal to 2, in that case the binary representation would be nothing but binary representation would be 1 0, right? So you have this bit is set and the position for this bit is nothing but 2, right? The position of this bit is 2 and there is only one set bit, only one bit is there which is 1, so that's why you'll return yes for it. Like if you have n is equal to, let's say 8, so what does 8 mean? 0 0 and 1, like 1 2 4 8, like this, right? So here you can see that only one bit is set, right? This particular bit is only set, so the position for this particular bit is what? The position is nothing but 4, right? Is this part clear to everybody? Okay, this part must be clear to everyone. Like if I have, like I'll be explaining for some of the basic test cases, so let's start discussing for them. So like let's say all of you can give me a +1 in the chat and like the video as well, right? Up till now if things are clear to all of you, right? And so that we can continue. If you have n is equal to 0, then the binary representation of that particular, this number n would be 0, and if it is 0, the binary representation is 0, so that means that there is no bit. So if there is no bit, then I'll return -1, right? I'll return -1 for this because there is no set bit, right? If I needed at least like one set bit should be there, not more than one, not less than one, exactly one bit should be set, but this bit is 0, so that's why I'll say that okay, the complete number is 0, so I'll not have anything, right? If I have n is equal to 1, in that case if I have to do the binary representation, right? So the binary representation would look like what? The binary representation would be 1. If the binary representation is 1 itself, so that means there is one set bit, right? The total number of set bits are 1. So in this case what I'll do, I'll return 1 because the position of the set bit is also 1, right? Now if my number n is equal to 2, if my number n is equal to 2, then the binary representation for that particular number would be 1 0, right? 1 and 0, right? So this is nothing but 1, this is 2. So like binary representation is 1 0 for 2, right? So this is 1 0. So what is the position of this? So the position is nothing but the second from the left you count the position, so position is 2, right? Is this much part also clear? Now if n is equal to 3, right? So in this case you will return 2 for this case, right? Now if n is equal to 3, so the binary representation would be nothing but 1 and 1. Now the question says that only one bit should be set, right? The question is saying that only one bit should be set, only one bit in the binary representation should be 1, but there are more than 1 bits here which are 1, so that's why I'll return a -1 for this case. Is it clear to everyone? Like up till now things are clear for all the 4 cases that I have discussed. Is this much part clear, so that I can move for further numbers, right? Up till now, if things are clear to everyone, just let me know in the chat. Is this much part clear to everyone? Please write clear in the chat. I can see a lot of people are watching, so you can consider to like the video as well, so that we have a good start, right? This much part of the problem is clear to everyone. Give me a +1 in the chat if this much part is clear, right? Now next up, what I'll say is, let's say if I have n is equal to 5, right? If I have n is equal to 4, if I have n is equal to 4, so the binary representation of it would be 1, 0 and 0. So if I have this representation, so I can see that this is the number that is 1, right? This only one bit is set as 1, right? Hi Anushka, right? Only when one bit is set as 1. So in that case the position is 3, right? From the left you are counting the position. This is the first position, this is second, this is the third position, so that's why you write it like this. Now if you have n is equal to 5, like we'll stimulate it for some cases, right? If the number is equal to 5, then the bit representation, binary representation for it would be 1, 0, 1. Now I have more than one bit set, right? This bit is also 1, this bit is also 1, but I need to return the position of all those numbers, for all those numbers who have only one bit as set. Only one bit should be 1 in their representation, right? But here more than one bit is 1, right? So in this case I'll return a -1, right? I'll return a -1. If I have n is equal to 6, so what will be the binary representation for it? The binary representation would be something like 1, 1 and 0. In this case also I can see that there are more, right? This is 1, this is 2, this is 4, yeah. So this is the number 6. So I can see that there are more than 2 bits, so I'll return -1. Up till now if things are clear, please write clear in the chat, right? Now if I have n is equal to 7, assume that I have n is equal to 7. So the representation of 7 is what? The binary representation of 7 is nothing but this 1, 0, that is 1, 2, 4, and like, yeah. So the representation is 1, 1, 1, 1, right? So like this is the representation for 7. So in this I can see that I just need to return the position of that bit. For that particular number I need to return the position which has only one set bit, but in this question, in this particular thing, I can see that there are more than one set bits. So in this case also I'll return a -1, right? Please write agree in the chat if you agree with me, right? Now let's move a little bit down as well, right? Now if you have n is equal to 8, if you have n is equal to 8, so the binary representation for it would be nothing but like this 1, 0, 0, 0, right? Like this. So I have just one bit set, so I'll return what? I'll return 4, because 4 is the position. This is the position 1, 2, 3 and 4, position 4, right? Now if can you observe some pattern? Can you observe some pattern? If I say that n is equal to 2 was one such number, for n is equal to 2, its representation was 1, 0. For n is equal to 4, its representation was 1, 0, 0. For n is equal to 8, its representation was 1, 0, 0, 0. For n is equal to 16, the representation for it would be what? 1, 0, 0, 0, 0, right? Like this. Can I say that if a number is power of 2, if a number n is power of 2, only in that particular situation it will be having only one bit set? Can I say this? Do you agree with me? Like all the odd numbers or any other numbers, like if you take 6, so 6 is nothing but 1, 1, 0, right? So this is not set, right? This is not having just one bit as set, right? Only power of 2 will have one bit. Yeah, Sudhanshu Kansal is right. Is it clear to you, Pranav, Anushka, Mahesh and others? I hope that this part is clear, right? So if it's clear, you can hit the like button. You can consider giving a like. So the number should be power of 2. Now the thing is that you know this question, right? But like 2 to the power 0 is 1, right? So this number is also there. 2 to the power 1 is 2. 2 to the power 2 is something like a 4, right? These are the numbers, like powers of 2. All those will be your answer, right? They will be included in your answer. But what will not be included in your answer? So any number which is having more than one set bit, right? Which is having more than one set bit. So if my n is 0, if the number itself is 0, then also I'll return a -1, right? Then also I'll return a -1. And if the number is having more than one set bit, then also I'll return -1. Now tell me one thing. If n is equal to 8, what are the total number of what is the position of the set bit? Can I say that the binary representation of n, right? The binary representation of n would be nothing but 1, 0, 0, 0, right? So this is 1, 2, 4 and 8, right? So what is the position? This is 1, this is 2, this is 3, this is 4. So the position is 4. So you'll say, okay, can we get some pattern, right? The thing is that can we get some pattern? If n is equal to 4, so the representation is 1, 0, 0, 0, right? So can I get some pattern? I can see this, this, this. So this position is there. So the position is 3. Can I get some pattern? If I do a log 2 with the number n, what will I get? If I do log of 2 8, so this is nothing but this becomes log of 2 to the power 3, right? So this is 3. So if I do log of n for when n is equal to 8, so if I do log of 2 when n is equal to 8, so I'll get 3. If I add 1 to it, can I say that I will get the position? So position is nothing but position is log of base 2 n, right? Like this, plus 1. This is the position for the set bit. If the number is having only one set bit, then this is the position. Please give me a +1 in the chat and like the video if this much part is clear, right? If my n is equal to 16, so what is the representation? Like something like this, 1, 2, 4, 8, yeah, 1, 2, 4, 8 and 16. So this is the 16, right? So this is what, if I take log base 2 n, right? If I do log base 2 n, right? So what will I get? I'll get log 2, 2 to the power 16 is 2 to the power 4. So this would be nothing but 4, and the actual position is what? 1, 2, 3, 4, 5. So the position is 5. So that's why you do log 2 base n plus 1, right? So this is the formula, log 2 n plus 1, right? So you do add 1, so you get 5, right? So this is the position. This is how you will get the positions. But now the thing is that you want to find that, now you know that if a number is, there are two situations. If a number is power of 2, if a number is power of 2 and not power of 2, right? So if a number is power of 2, then the answer would be directly what? Log of 2 n plus 1, right? This would be the position of the set bit, right? Please write clear in the chat if this much part is clear. If it's not a power of 2, in that case you simply return -1. Now, how will you check? How will you check that whether a number is a power of 2 or not? Like whether it has, forget about this power of 2, just think that if it has only one set bit, right? So how will you check that if it has one set bit or more? One set bit or more, how will you check it? That's the task that lies ahead of us, right? How will you check that if a number is having more than one set bit or not, right? So if I talk about this much part, but log n gives always integers. Yeah, log n will give integers, so you write log of base 2 n plus 1, right? So that's why you will get the answer, right? For 8, the position would be what? 1, 0, 0, 0. So 1, 2, 4 and 8. So the position would be 4. So log 2 n plus 1. So log 2 8 plus 1. This would be, 8 is nothing but 2 to the power 3. So this will give me 3. 3 plus 1 would be 4, right? So that's how I'll write the answer, right? So you're doing bit masking. Now the guy is saying that either there could be several ways, right? Either you convert, right? See how to see the number of bits, right? How to, one way could be to count all the set bits, right? All the set bits, right? All the set bits means the bits which are 1. Right, all the bits which are 1. So if I have any number n, so first of all I do its binary representation. Let's say n is equal to 6, so I do its binary representation. This would be nothing but 1, 1 and 0, something like this, right? So if I have this number, so I just count all the set bits and I see what is the total number of set bits, right? If there are more than one set bit, if there is more than one bit, which is 1, in that case I will return a -1, right? This could be one of the approaches, but there is second alternate approach of doing this, right? What I can do is, what if n is equal to 3? If n is equal to 3, how many bits does it have? It has 1 and 1, right? What is n minus 1? N minus 1 is nothing but 2. What is the representation of 2? 2's representation is 1 and 0. If I do an AND with these two things, if I do an AND, right? If I do n and n minus 1, what do I get? I am applying an AND operation. So if 2 bits are 0, so you'll get 0. If 1 bit is 0, 1 bit is 1, so you'll get 0. If 1 bit is 0, another bit is 1, so you'll get 0 again. If 1 bit is 1, another bit is 1, then only you'll get 1, right? So you'll get 1 here. If you are doing AND, you'll get 1, you'll get 1 and you'll get 0. So you're getting some number, right? You're getting some number. But so in this case, you can see that 3 With 3 you are getting some positive number, right? You are getting some positive number, and here the number is 1 and 2, so the number is 2, right? Here the number is 2. So if you are doing n and 1, right, if you are doing n and n minus 1, like let's do n and n minus 1 for the number when log base 15 will give, not my answer, like if you have 15, right? So you are talking about 15. So 15 is like 15 has more than one set bit, right? So you will never write 15. 15 is what? 15 is represented like this, 1 0. What is the representation of 15? 1 2 4 8 8 4 12. Like 15 would be something like this, I guess, right? 15 would be something like this. 15 would be something like this, right? But you just have to return for all those numbers. Sudhanshu, you just have to return the set bit for all those numbers which are having only one bit is set, right? Only one bit is set. All the numbers which are powers of 2, right? All the numbers which are power of 2, or you, right? This particular thing is not, this will never be included in the answer. Only one, you have to return the position for all the bits only where one bit is set, right? Okay. Perfect. This is what you have to do. Now if you take n is equal to 4, let's take n is equal to 4. Right, let's take n is equal to 4. So if you have n is equal to 4, then what you do with n is equal to 4? If you do n, what is n minus 1? The representation of 4 is 1 0 0. What is n minus 1? N minus 1 is nothing but 3. So 3, what is the representation of 3? 3 is nothing but 0 1 1, like this. If I do and for both, if I do n and n minus 1, so what do I get? I get 0. If I do n and n minus 1, what do I get? I get 0, right? So what do you observe? What do you observe? When n was 3, I did n and n minus 1, so I was getting some positive number, some number, right? But if the number has only one set bit, if the number has only one set bit and I do n and n minus 1, then it would give me 0, right? This is what I will get. Okay, is this much part clear to everyone? I hope that this part is clear, right? So if you want to check that whether a number is having set bits or not, so if you do n and n minus 1 and it gives you 0, so in that case the number will have only one set bit, and in that case if this is true, then in that case what you do, you simply return nothing but this thing. You simply return nothing but log of n with the base 2 plus 1, right? You do this, you just return this part, else you return minus 1, right? Else you return minus 1, and you need to check if the number is n is equal to 0. If the number given to you is 0, then in that case also you will return minus 1, right? I hope that this part is clear. Anushka, is it clear to you? Ankit Maurya, is it clear to you guys? I hope that it's clear to all of you, right? So let me show you the code. I'll just copy this code first of all. So let me just submit this code so that I can show that it's working fine. So this is, you can see that it is getting accepted. Yeah, it got accepted for all the test cases. Now let me copy this code here and show you. So what I've done is, as I've told you, right? As I've told you, if the number is 0, then in that case you return just minus 1, right? If the number is 0, then in that case you return minus 1 because it will not be having any set bit. If the number will have only one set bit, then n and n minus 1 would be equal to 0, right? There could be one way that you can count it, right? There's one way that you can count it. Otherwise, you do n and n minus 1 and is equal to 0. You just return log of 2n plus 1 like this, right? This is what you do. Log of 2n plus 1, that will be the position if n and n minus 1 is equal to 0. So that means there is only one set bit, right? You can try to dry run it as well. Otherwise, if that is not the case, so it will have more than one set bit. In that case, you need to return minus 1. So this was the question. If its question is clear to everyone, please like the video and please give me a +1 in the comments, right? Okay, is it clear to everyone? Is this question clear to everyone? Please let me know in the comments, right? So this problem previously, the tag that has been given to you is Microsoft. So this problem was asked in Microsoft. So it was an easy problem. Basically, if n is equal to 0, then in that case you return minus 1. Otherwise, you check if n and n minus 1, if this is equal to 0, then in that case what you do, you simply return log of n with the base 2 plus 1. That would give you the position of the set bit. Otherwise, if that is not the case, then in that case you will be having more than one set bit. So in that case you have to return minus 1 for this question. This is the question, and you can try to implement it by yourself. Like you just go after the session, and the time complexity would be like it's order of 1. It's a constant time, order of 1, because this is taking nothing. Here I'm checking in order of 1, and here I'm taking just direct the log. So it's order of 1 for my code. Okay, it's constant time and constant space. So this is what I've done. So Shudhanshu, I hope it's clear to everyone. If everyone is clear with this, so please write clear plus plus in the chat before going. And I'm here for you can say 60 seconds more if you want to ask something or say something. So you can do that. And before that, like we also have a channel that is Code Era. So you can consider to watch this channel. On this channel, I do the Lead Code daily challenge live streams every day. Apart from this, we are also doing Code Forces video editorials for the Code Forces round, and at Coder rounds, Lead Code weekly and bi-weekly challenges. So you can consider to subscribe our channel. You can just search Code Era in the YouTube and you'll get this channel, or you can find it in the featured channel of this particular channel as well. So thanks a lot for watching, and in case if you have any doubts or if you have any positive feedback, so after this stream is over, you can give that in the comments, right? It will take log n time for calculating log calculation. Yeah, but it is still constant, right? Because the n value is very small, right? The n value that will be given to you is very small, so that's why it will like it. You can consider if the n value is very small, in that case it will be constant. If the n value is something close, if the n value is something close to 10 to the power 8, then it will be log of n, right? It will be log of n when the n value is large, but you can also assume it to be constant, right? Okay, so this was the problem. Like if the n value is large, then the time complexity would be log of n, order of log of n, right? So this was the problem of the day for yesterday. Try to solve today's problem of the day as well. The today's problem of the day is Excel sheet part 1. It has been asked in Amazon, so try to solve it, and tomorrow we'll be looking into the solution of this particular problem. Thanks a lot for joining in, and make sure to subscribe Code Era as well. So this was it from my side for today.